Our final theorem of the section is the Cauchy mean-value theorem, which is a generalization of the mean-value theorem that we saw a little earlier. The previous mean-value theorem just used one function, f, one differentiable function. The Cauchy mean-value theorem is going to use two functions. I am not going to prove the Cauchy mean-value theorem. The proof is in the text, but it uses the intermediate value property that we talked about a little earlier. I believe it was theorem 4.11. Okay, let's state the Cauchy mean-value theorem. If f and g are continuous on the closed bounded interval, ab, and differentiable on the open interval, ab, then there is a c somewhere in between a and b such that this formula holds. It's interesting because it's taking the derivative of g and the derivative of f at the same value of c in the interval. And let's write this slightly differently. You'll see it frequently written in textbooks as, I'll put it in brackets here, or you could write it like f of b minus f of a all over g of b minus g of a. Equals f prime of c over g prime of c. I might refer to this in just a few minutes. Just two alternate ways of writing the same thing. I prefer this one because we don't have to worry about when g of a and g of b are the same number and we get a division by 0. So in this case, you need to assume that g prime of c is not 0, or this denominator is not 0. Well, the Cauchy mean-value theorem, as mentioned, is a generalization of the original mean-value theorem. And, okay, that's the statement of the theorem. Just note that if we let g of x be the identity function, g of x equals x, on AB, on the interval a to b, then we can say that we know what g of b is and we know what g of a is. Since it's the identity function, g of a equals a, g of b is equal to b. In general, well, g of x is equal to x, but we also know the derivative of this function. And g prime of x is just a 1, right? Which implies that g prime of c is equal to 1, because the derivative is equal to 1 everywhere in the interval a to b. So therefore, c being on that interval, g prime of c is equal to 1. So by substituting what we've got over here into what I labeled the star there, what do we get? We get f of b minus f of a over b minus a, because g of b is b and g of a is a. And since g prime of c is a 1, we just get f prime of c. And that looks just like the original mean-value theorem. And that's the end of this section, but in the next section we will use the Cauchy mean-value theorem to prove something that we all remember from calculus, L'Hopital's rule.